enthusiasts. Today, we are going to discuss about proving triangle congruence using some problems from the Book of Geometry by Moise and Down, Part 2. Example number 1. If a median of a triangle is perpendicular to the side it bisects, then it bisects the angle opposite that side and the triangle is isosceles. The hypothesis of this sentence is, if a median of a triangle is perpendicular to the side it bisects, and the conclusion is, it bisects the angle opposite that side and the triangle is isosceles. Let us create an illustration. The hypothesis talks about a median of a triangle. So we create a triangle ACB and the median CD. It also says that CD, or the median of triangle, is perpendicular to the side it bisects. So another part of the hypothesis is that CD is perpendicular to AB. In the conclusion, it says that the median bisects the angle opposite that side. So meaning CD bisects angle C. And that the triangle is isosceles. Meaning, we need to prove also that AC and BC are congruent so that this triangle ACB is isosceles. Let's have the restatement. Given, line segment CD is a median, and that line segment CD is perpendicular to line segment AB. We need to prove that line segment CD bisects angle C and that triangle ABC or ACB is isosceles. We were given that line segment CD is a median. By the definition of a median, we can say that line segment AD is congruent to line segment DB. Also, line segment CD is perpendicular to line segment AB. The consequence is, angle CDA is congruent to angle CDB because these are two right angles. Now, we need to prove that CD bisects angle C. It means that we need to prove first that angle ACD is congruent to angle BCD. We also need to prove that triangle ABC is isosceles, meaning we need to prove first that line segment AC is congruent to line segment BC. Now to do this, we need first to prove that these two triangles are congruent. We need three corresponding parts. Notice that we only had two before, this and this. Of course, the third part is the common side. And so these two triangles are congruent by the ASA postulate. And since these two triangles are congruent, then we can say that its corresponding parts, the corresponding angles and the corresponding sides are congruent. We have now the formal proof. Statement 1, line segment CD is a median, given. Statement 2 is the consequence of statement 1. Line segment AD is congruent to line segment DB by the definition of a median. Statement 3 is another given. Line segment CD is perpendicular to line segment AB. Statement 4 is a consequence of statement 3. Angle ADC and angle BDC are right angles because perpendicular lines form right angles. Angle 5 is the consequence of statement 4. Angle ADC is congruent to angle BDC because all right angles are congruent. Statement 6. Line segment CD is congruent to line segment CD by reflexive property. Statement 7. Triangle ADC is congruent to triangle BDC by SAS postulate, considering the side number 2, number 5, and number 6 statements. Statement 8. Angle ACD is congruent to angle BCD by CPCTC or CACTC. Statement 9 is the consequence of Statement 8, that line segment CD bisects angle C by the definition of bisect. Take note, this is a part of the conclusion. Statement 10, angle AC is congruent to line segment AC is congruent to line segment BC by CPCTC or particularly CSCTC. Statement 11 is the consequence of Statement 10. The triangle ABC is isosceles by the definition of an isosceles triangle, which is the end of our proof. QED. Example number 2. In the figure, A, B, C, and D are non-coplanar, and AB is equal to AC equal to AD equal to BC equal to BD equal to CD. Q and R are midpoints of line segment AC and line segment AD respectively, and P is any point of line segment AB. Prove that triangle PQR is isosceles. Now, we can understand this better if we write it this way. AB is equal to AC is equal to AD is equal to BC is equal to BD and is equal to CD. Q and R are midpoints of line segment AC and line segment AD. So that means AQ is equal to QC and AR is equal to RD. We need to prove that PQR, triangle PQR, is isosceles. We can only prove that triangle PQR is isosceles if we can prove that line segment PQ and line segment PR are congruent. How is this going to be possible? Now, if you look at this triangle and this triangle, notice that these two triangles could be proven to be congruent. Are there three corresponding parts? Yes. This part is congruent to this part. This angle is congruent to this angle. How is that possible? Well, I'll discuss more later. And this side AP is congruent to itself. Now, it's easy for you to understand. Now, how about these angles? How can we say that angle PAQ or angle BAQ is congruent to angle PAR or angle BAR or BAD? Now, notice that AB is equal to AC, which is equal to BC. So, it means that it is an equilateral triangle, which is equal to this another equilateral triangle, AB, AD, BD. Now, recall that equilateral triangles are also equiangular triangles. So, that means all its angles are also congruent. Since these are two equilateral triangles, then these are also two equiangular triangles. So, we can say that these two angles are congruent. So, AP is congruent to itself. So, how many parts do we have already? 1, 2, and 3. So, we can already say that triangle PAQ is congruent to triangle PAR by SAS postulate. Now, how can we make triangle PQR as isosceles again? Okay, if we can prove that PQ and PR are congruent. Are this possible? Yes. By CPCTC, since we have already mentioned a while ago that these two triangles are congruent. So here is the formal proof. Statement 1, AB is equal to AC equal to AD equal to BC is equal to BD is equal to CD, given. Statement 2, Q and R are midpoints of line segment AC and line segment AD respectively, and P is any point of line segment AV, given. Statement 3 is the consequence of statement 2, that line segment AQ is congruent to line segment QC and line segment AR is congruent to line segment RD by the definition of a midpoint. Oh, by the way, in the previous statement, the notation uses the equal sign. So there is no notation for the line segment. So we can also use this notation here. So AQ is equal to QZ and AR is equal to RD. Then, statement number 4 is the implication or the consequence of statement 3 and 1, that AQ and AR are equal by transitive property. Statement 5, triangle BAC and triangle BAD are equilateral triangles by the definition of an equilateral triangle. Statement 6 is a consequence of statement 5. Angle BAC is congruent to angle BAD because equilateral triangles are equiangular. Statement 7, line segment AP is congruent to line segment AP by reflexive property. Statement 8, triangle PAQ is congruent to triangle PAR by SAS postulate, while considering statements 4, 6, and 7. Statement 9, line segment PQ is congruent to line segment PR, or PQ is equal to PR by CP-CTC or CS-CTC. Finally, the conclusion, triangle PQR is isosceles by the definition of an isosceles triangle, QED. Example number 3. Let L be the edge of two half planes H sub 1, H sub 2. A and B are 2 points of L. M is a point in H sub 1 and R is a point in H sub 2, such that angle MAB is congruent to angle RAB, AM is equal to AR, and B is not between M and R. Prove that triangle MRB is isosceles. This is the illustration obtained from this statement. So, sometimes problems given in the books may not be giving you a figure. So, it is you who are going to create an illustration from what you were given. Now, let L be the edge of two half planes A sub 1 and A sub 2. A and B are 2 points of L. M is a point in H sub 1 and R is a point in H sub 2, such that angle MAB is congruent to angle RAB. AM is equal to AR and B is not between M and R, meaning B is somewhere below and not here. Prove that triangle MRB is isosceles. So for us to prove that triangle MRB is isosceles, we need to prove first that MB is equal to RB. How can we do that? How can we prove that MB is equal to RB? So we consider this triangle and this triangle. How can we make these two triangles congruent? Well, we have 3 corresponding parts already. This one, and of course the common side. So by SAS postulate, these two triangles are congruent, and by CP-CTC, these segments are congruent. Here is now the formal proof. Statement 1, let L be the edge of two half planes H sub 1 and H sub 2, given. Number 2, A and B are 2 points of L, given. Number 3, M is a point in H sub 1 and R is a point in H sub 2, given. Number 4, angle MAB is congruent to angle RAB, given. Number 5, AM is equal to AR, given. And number 6, B is not between M and R, given. Whew. Okay, statement 7. AB is equal to AB by reflexive property. And so, statement 8, triangle MAB is congruent to triangle RAB by SAS postulate while considering statements 4, 5, and 7. Statement 9, MB is equal to RB by CPCTC or CSCTC. Finally, triangle MRB is isosceles by the definition of an isosceles triangle. QED. Example number 4. E is the midpoint of line segment AB. Line segment AD is perpendicular to line segment AB. Line segment BC is perpendicular to line segment AB, and angle ADE is congruent to angle BCE. Prove that angle ADC is congruent to angle ACD. E is the midpoint of line segment AB, so it must imply that line segment AE is congruent to line segment EB. Line segment AD is perpendicular to line segment AB. Line segment BC is perpendicular to line segment AB. So it must imply that angles CBE and DAE are right angles. Angle ADE is congruent to angle BCE. Prove that angle AE is congruent to angle ECD. How can we make these two angles congruent? This is possible if we can prove that these sides are congruent by the isosceles triangle theorem. How can we prove that these sides are congruent? If we can prove that these two triangles are congruent. How can we prove that these two triangles are congruent? If we have three corresponding parts congruent. And fortunately for us, there are already three corresponding parts available. So here is the formal proof. Statement 1. E is the midpoint of line segment AB, given. Number 2, line segment AE is congruent to line segment EB by the definition of the midpoint. Of course, statement 2 is the consequence of statement 1. Statement 3, line segment AD is perpendicular to line segment AB, given. Statement 4, angle DAE is a right angle because perpendicular lines form right angles. This is a consequence of statement 3. Statement 5. Line segment BC is perpendicular to line segment AB, given. And statement 6. Angle CBE is a right angle because perpendicular lines form right angles. Statement 6 is the consequence of statement 5. Statement 7 is the consequence of statements 4 and 6. Angle DAE is congruent to angle CBE because all right angles are congruent. Number 8. Angle ADE is congruent to angle BCE, which is given. Statement 9. Triangle ADE is congruent to triangle BCE by SAA theorem, considering statements 2, 7, and 8. Statement 10. Line segment DE is congruent to line segment CE by CPCTC or CSCTC. Statement 11, our conclusion, angle ADC is congruent to angle ACD by the isosceles triangle theorem. QED. Example number 5. E is the midpoint of line segment AB. Line segment AD is perpendicular to line segment AB. Line segment BC is perpendicular to line segment AB, and DE is equal to CE. Prove that AD is equal to BC. Example number 5 is similar to example number 4. So, notice that E is the midpoint of AB. Again, line segment AE is congruent to line segment EB. Also, line segment AD is perpendicular to line segment AB. And line segment BC is perpendicular to line segment AB, so that angles DAE and CBE are right angles and are congruent. And DE is equal to CE. Prove that AD is equal to BC. How can we prove that DA is equal to C? Of course, first, we need for these two triangles to be congruent. Now, observe that we have three corresponding parts. Is that called SSA theorem? Well, we do not have an SSA theorem. Instead, we have a hypotenuse leg theorem. Since these two triangles are right triangles, and notice that their hypotenuse as well as one leg are congruent, then we can say that these two triangles are congruent. And by CPCTC, AD is equal to BC. So, statement 1, E is the midpoint of line segment AB given. Statement 2, line segment AE is congruent to line segment EB by the definition of a midpoint. Statement 3, line segment AD is perpendicular to line segment AB given. Statement 4, angle DAE is a right angle because perpendicular lines form right angles, a consequence of statement 3. Statement 5, line segment BC is perpendicular to line segment AB given. And statement 6, angle CBE is a right angle because perpendicular lines form right angles. So, statement number 7 is the consequence of the previous statements. Triangle DAE and triangle CBE are right triangles by definition of a right triangle. So notice that in the previous example, the first 6 statements and reasons were the same. Okay, statement 8, DE is equal to CE and given. Then number 9, triangle ADE is congruent to triangle BCE by the hypotenuse leg theorem, while considering statements 2, 7, and 8. Finally, AD is equal to BC by CPCTC or CSCTC. QED. Example number 6. AE is equal to BC, ED is equal to CD, and G is the midpoint of line segment AB, and angle E is congruent to angle C. Prove that line segment DG is perpendicular to line segment AB. We were given AE and BC to be congruent or equal. We were also given that ED and CD are equal. We were also given that G is the midpoint of line segment AB, which implies that line segment AG or AG is equal to GB. We were also given that angle E is congruent to angle C. Now we need to prove that line segment DG is perpendicular to line segment AB. Now how can we make this perpendicular? If we can prove that these are right angles. How can we prove that these are right angles? If we can prove that these two triangles are congruent. How can we make these two triangles are congruent? Well, we need 3 corresponding parts. Now, how do we get these 3 corresponding parts when we only had 1? Okay, we can have these 2 triangles, 2 segments to be equal by using these 2 triangles. Are these 2 triangles congruent? Yes, by SAS or SAS postulate. And so, by CPCTC, AD is equal to BD. So, we now have 2 corresponding parts. We have one more, the common side, DG. So, these 2 triangles are now congruent by SSS postulate. And so, that these angles are congruent by CP/CTC. For these angles to be congruent, it means that these angles must be right angles. And if these angles are right angles, then DG and AB are perpendicular. Here is the formal proof. AE is equal to BC given, ED is equal to CD given, G is the midpoint of line segment AB given, AG is equal to BG by the definition of a midpoint. This statement 4 is a consequence of statement 3. Angle E is congruent to angle C given. And triangle DAA and triangle DCB are congruent, these two triangles, by SAS postulate considering statements 1, 2, and 5. AD is equal to BD by CP/CTC. DG is equal to DG by reflexive property. And so, triangle DAG is congruent to triangle DBG by SSS postulate considering statements 4, 7, and 8. Angle DGA is congruent to angle DGB by CP/CTC or CA/CTC. Statement 11, angle DGA is supplementary to angle DGB because this is a linear pair or a straight angle. Definition of supplementary angles is the reason for statement 11. Statement 12, angle DGA and angle DGB are right angles because angles that are congruent and supplementary are right angles. Finally, our conclusion, line segment DG is perpendicular to line segment AB because perpendicular lines are formed by right angles. QED. Proving geometrical statements does not only require intelligence and correct reasoning. It also requires patience and determination. Full concentration, optimism, and organized thought are also important to be successful in this area of learning. Thank you very much. Remember, math is easy to learn when one learns with enthusiasm. Bye!